Hi everyone, this is Mishal Salim, and in this video we will learn how to rationalize surds. So let's get started. Here's a question which is -9 over square root of 10. So now we will see how to rationalize this surd. Actually, by rationalizing surd we mean that when there is an irrational number in the denominator, then we must rationalize it. By rationalizing I mean that convert it into a rational number. When there is an irrational number in the denominator, then we can't operate on this kind of fractions. Let's say if we are adding this fraction to some other number or some other fraction, then we can't, because there is an irrational number in the denominator. So first we must rationalize this denominator. After that we can operate on this. Okay, so let's see how can we rationalize the denominator, how can we rationalize a surd. In order to rationalize it, we need to times it with something. Okay, so if I times under the root 10 with under the root 10, then square root of 10 times square root of 10 is equal to 10. So that's it, it's that simple. Also, after simplifying this, we will get 10 in our denominator and it will be rationalized. So now I did something additional, something extra to this fraction to eliminate the effect on this fraction of this additional thing. We must also multiply it in the numerator to cancel the effect on this fraction, because you can see that square root of 10 divided by square root of 10 equals 1, and this fraction times 1 equals this fraction again. So now it's okay mathematically, there is no effect on this fraction. So let's simplify it by timesing it with this fraction. So we will get an equivalent fraction of this fraction. So -9 times square root of 10 is actually -9 into square root of 10, and then square root of 10 times square root of 10 is actually equal to, let me write it here, is actually equal to square root of 10 square, because we are timesing it 2 times. So we can cancel square with square root and we'll get 10. So 10 in our denominator. And that's it. That's how you rationalize a surd. This is our answer. So you must see after this that whether we can simplify it further or not. In this case we can't simplify it further, so we will leave it here. This is our answer. This is actually really easy. Now let's practice some more questions. Okay, so here we have another question. Let's practice it. It's 10 over square root of 7. So in order to rationalize this, again we need to times it with square root of 7, and then again square root of 7 in the numerator also, to eliminate the effect on this fraction. Okay, so now 10 times square root of 7 is 10 times 7, and over square root of 7 times square root of 7 is actually 7, because square root of 7 times square root of 7 is actually square root of 7 square. So you can cancel square with the square root and we get 7. So this is our answer. We can't simplify it further. That's how you rationalize surds. Okay, let's practice another question, which is 9 over square root of 45. 9 over square root of 45. This is easy. We just have to times it with square root of 45 over square root of 45. again square root of 45. So 9 times square root of 45 is 9 times 9 into square root of 45, and over 45 square root times square root of 45 is actually 45. Now you're familiar with this. Now I can write directly 45 here. Okay, so if you look at this fraction, look at this surd specifically, we can simplify it. So there is some simplification possible. So let's simplify it. Okay, so if I want to simplify it, first of all I can do this, that 9 times 1 is 9, and then 9 times 5 is actually 45, and I can write, instead of 45 I can write 9 times 5, 9 times 5, and then over 5, and then we can just write the square root of 9 is 3, so 3 will come out of the root, and inside the square root there is just 5 left, so let's write 5. So 3 into square root of 5 over 5. Now this is our final answer. That's how you rationalize it and then simplify it. Okay, now we have another question. What if we have two terms in the denominator? So how to rationalize this now? So let's think of something, that how can we rationalize denominators like this, in which we have two terms. So this is really easy. First you have to take conjugate of this denominator. So what is conjugate? Let me tell you. So 4 plus square root of 5, and then we take conjugate of this. So conjugate of this expression is to convert or to change the sign of the last term. That's how you take the conjugate. So 4 plus square root of 5, the conjugate of this expression is 4 minus square root of 5. So you take the conjugate of this fraction and then you times it with the numerator and with the denominator, like 4 minus square root of 5, and then over 4 minus square root of 5. Okay, now we can rationalize it. This is really easy now, because this looks like a formula, an algebraic formula, because a plus b, it looks like a plus b into a minus b, which is equal to, let me first simplify the numerator, then we'll come to the denominator. So negative 5 times 4 is actually negative 20. So negative 20, then negative times negative is positive, so let's write positive, and then 5 times square root of 5. So 5 times square root of 5 is 5 into square root of 5. Then in the denominator we have a plus b into a minus b, an expression like this, which is an algebraic formula. So a plus b, and then times a minus b is actually equal to a square minus b square, a square minus b square. So here we have for a we have 4, and for b we have square root of 5. So let's write this. It will be 4 square and minus square root of 5 square, square root of 5 square. So in the next step, let's simplify it. So it will be negative 20 plus 5 into square root of 5, and in the denominator we have now 4 square is 16, and we can cancel this square with this square root, so we'll get 5. So 16 minus 5 actually, and this is equal to negative 20 plus 5 into square root of 5 over 16 minus 5 is 11. So this is our final answer. That's how you rationalize surds in which there are two terms in the denominator. So you take the conjugate of it and then you times it in the numerator and denominator and then simplify it. It's that easy. Now let's practice another question. Okay, so now here we have another question in which there are also two terms in the denominator. So how can we rationalize the denominator in this case? So it's again really simple. Take the conjugate of this expression, which will be 4 plus square root of 10. So 4 plus square root of 10, and also divide it by 4 plus square root of 10. Okay, now you have to multiply it. Negative 12 times 4. So negative 12 times 4 is negative 48. So negative 48. And then negative times positive is negative, and 12 times square root of 10 is 12 into square root of 10. Okay, now in the denominator again we get the formula, the algebraic formula, which is a minus b into a plus b. So when there are two terms in the denominator, you must make it like this. You must make it possible to become the algebraic formula, to simplify it through the algebraic formula. It's really easy to simplify it through the algebraic formula. That's why we take the conjugate of this expression and then times it within the numerator and denominator to make the algebraic formula in the denominator. So a minus b into a plus b is a square, and then minus b square. Okay, so this will be negative 48, then a negative 12, into square root of 10, and then over 4 square is 16, and if we cancel this square with the square root we get 10, so it's minus 10. Okay, this will again equal to negative 48 minus negative 12 into square root of 10, and then in the denominator we get 16 minus 10 is 4. Sorry, 6 actually. It's 6. My bad. Okay. Now we can simplify it further. There is 6 is 48 and 12 both are multiple of 6. So now we will factorize the numerator. We can take here negative 6 is our common factor, or positive 6. So we will get now 6 as common factor, and inside there will be left 6 times 8 is 48, so negative 8 actually. So negative 8, and then 6 times 2 is 12, and then square root of 10. So actually there are two terms, negative 48 and then negative 12 into square root of 10. This is one term and this is the other term. So in these both terms we took c as a 6 as common factor, and in the first term there is a negative 8 left, and in the second term there is negative 2 of square root of 10 left. Okay, now in the denominator there is 6, and now we can simplify it like 6 times 1 and 6 times 1. So we are just left with negative 8, negative 2 into square root of 10, and this is our final answer. That's how you rationalize the denominator. That's all. Thank you.